This is our additional topic over Pythagorean Theorem. A squared plus b squared equals c squared. So here's our right triangle. Some vocabulary for the triangle may be like this. A and B are called the legs. If you have an angle inside of the triangle, you may be referencing it based on that. If you do that, B would be the opposite side to this reference angle, theta. A lot of times they call it y. A would be the adjacent, the side next to the reference angle, theta. And it's a lot of times called x. And then the longest side, C, that's our hypotenuse. It's the side that's opposite to the 90-degree angle. And it's a lot of times called R. Here's our first example. We have 3, something, and 5. So that's A, and that's C. So we're going to plug it into the formula to find out what our missing value is. 3 squared plus b squared equals 5 squared. 3 times 3 is 9. And 5 times 5 is 25. From here, we want everything on one side except for the b. We're isolated, so let's subtract 9 from each side. So we have 16 equals b squared. Now to get this, we're going to take the square root of each side, square root, and the square cancels out, becomes 1. b equals 4. We're only going to do the positive answers on this one for today, although we could have plus or minus 4. But we're going to be talking about distances, so let's go with the positive numbers. So our missing side length is 4. Now, 3, 4, 5 is what is called a P-triple, a Pythagorean triple. It's basically a right triangle that has integer lengths. There are many others, but this is the one that comes up the most. Next, we have special right triangles. These are triangles that have special formulas that even if you have only one side, you can find all three, as long as you have these special angles, 45, 45, 90, or 30, 60, 90. So our two legs of the 45 triangle is both the same, x and x. So A is equal to B in that case. And whatever that number is, you just put a square root 2 next to it for the hypotenuse. On the other special right triangle, 30, 60, 90, the opposite of 30 is x. The adjacent, you just have that number and put a square root of 3 next to it. And the hypotenuse, the longest side, or C, we're going to multiply this number by 2. We're going to double it. So let's look at example 2. We have 3, 3, and something. Now, it should be 3 square root of 2. But let's check with the Pythagorean theorem. 3 squared plus 3 squared equals c squared. 3 times 3 is 9. 3 times 3 is 9. That equals c squared. 9 plus 9 is 18. Get the square root of both sides. The square root of 18 can be reduced. Recall from when we were simplifying radicals that we need to take out perfect squares. We could take out a 9. 18 divided by 9 is 2. There's no other perfect squares besides 1, so that would be our simplified radical. 3 times the square root of 2. And that's our c, which is the same thing as from our formula. So if you have 2 of the sides already, you can use Pythagorean Theorem to find that third side. But if you only have one of the side lengths, you'll have to use this property. Now, using the property in this case would be a lot easier and faster. In fact, you don't even have to simplify the radical with it. Let's look at example 3 now. We have a 30, 60, 90 triangle. So A, by looking at your special right triangle, should be x, which is what's in front of the square root of 3. So A should be 2. Let's make sure, though, using the Pythagorean theorem. 2 squared, no, A squared plus 2 square root of 3 squared equals 4 squared. So we have A squared plus 2 squared times radical 3 squared equals 16. 2 times 2 is 4, and the square root of 3 times the square root of 3 is just 3. 3 times 4 is 12. Carry everything else down. To get A by itself, we need to subtract 12 from both sides. So A squared equals 4. Take the square root, A equals 2. And that's what we had. So try the problems on the back and use your Pythagorean theorem and the 2 special right triangles to help you solve the problems.